wastes, and the process includes, as well, the transporting of wastes to transfer stations and/or disposal sites. To elaborate, the factors that influence the waste collection system include the following collection points. These affect such collection system components as crew size and storage, which ultimately control the cost of collection. The collection points depend on locality and may be residential, commercial or industrial. Collection frequency. Climatic conditions and requirements of a locality as well as containers and costs determine the collection frequency. In hot and humid climates, for example, solid wastes must be collected at least twice a week, as the decomposing solid wastes produce bad odor and leachate. Storage containers. Proper container selection can save collection energy, increase the speed of collection and reduce crew size. Most importantly, containers should be functional for the amount and type of materials and collection vehicles used. Containers should also be durable, easy to handle, and economical, as well as resistant to corrosion, weather and animals. Collection crew. The optimum crew size for a community depends on labor and equipment costs, collection methods and route characteristics. The size of the collection crew also depends on the size and type of collection vehicle used, space between the houses, waste generation rate and collection frequency. For example, increase in waste generation rate and quantity of wastes collected per stop due to less frequent collection result in a bigger crew size. Collection route. An efficient routing of collection vehicles helps decrease costs by reducing the labor expended for collection. Proper planning of collection route also helps conserve energy and minimize working hours and vehicle fuel consumption. Transfer station. A transfer station is an intermediate station between final disposal option and collection point in order to increase the efficiency of the system, as collection vehicles and crew remain closer to routes. If the disposal site is far from the collection area, it is justifiable to have a transfer station, where smaller collection vehicles transfer their loads to larger vehicles, which then haul the waste long distances. Collection vehicles. The collection vehicle selected must be appropriate to the terrain, type and density of waste generation points, the way it travels and type and kind of material. Small-scale collection and muscle-powered vehicles. Thus they are common vehicles used for waste collection in many countries and are generally used in rural hilly areas. Non-compactor trucks. Non-compactor trucks are efficient and cost-effective in small cities and in areas where wastes tend to be very dense and have little potential for compaction. These trucks are used for waste collection. They need a dumping system to easily discharge the waste. It is generally required to cover the trucks in order to prevent residue flying off or rain soaking the wastes. Trucks with capacities of 10-12 cubic meters are effective if the distance between the disposal site and the collection area is less than 15 kilometers. If the distance is longer, a potential transfer station closer than 10 kilometers from the collection area is required. Non-compactor trucks are generally used when labor cost is high. Compactor truck. Compaction vehicles are more common these days, generally having capacities of 12-15 cubic meters due to limitations imposed by narrow roads. The capacity of a compaction vehicle is similar to that of a dump truck. The weight of solid wastes collected per trip is 2 to 2.5 times larger since the wastes are hydraulically compacted. A compactor truck allows waste containers to be emptied into the vehicle from the rear, front or sides and inhibits vectors of disease from reaching the waste during collection and transport. Hauled container system. 1. Collection systems in which the containers used for the storage of wastes are hauled to the processing, transfer or disposal site, emptied and returned to either their original location or some other location are defined as hauled container systems. 2. There are two main types of hauled container systems. 1. Tilt frame container, 2. Trash trailer. 3. The collector is responsible for driving the vehicle, loading full containers and unloading empty containers and emptying the contents of the container at the disposal site. In some cases, for safety reasons, both a driver and helper are used. 4. Systems that use tilt frame loaded vehicles and large containers, often called drop boxes, are ideally suited for the collection of all types of solid waste and rubbish from locations where the generation rate warrants the use of large containers. 5. The application of trash trailers is similar to that of frame container systems. Trash trailers are better for the collection of especially heavy rubbish and often are used for the collection of demolition wastes at construction sites. Stationary container system. 1. Container systems in which the containers used for the storage of wastes remain at the point of waste generation, except when moved for collection, are defined as stationary container system. 2. Labor requirements for mechanically loaded stationary container systems are essentially the same as for hauled container system. 3. There are two main types of stationary container systems. I. Those in which self-loading compactors are used. E. Those in which manually loaded vehicles are used. 4. Container size and utilization are not as critical in stationary container systems using self-loading collection vehicles equipped with a compaction mechanism as they are in hauled container system. 5. Trips to the disposal site, transfer station or processing station are made after the contents of number of containers have been collected and compacted and the collection vehicle is full. This system is used for the collection of all types of wastes.